You may be wondering, do I have to learn all this? Do I have to write the code myself? The answer is no, because I am providing all the code for you, and we are not here to learn programming, we are here to learn physics. So by using these, we are going to learn how physics works. For example, in this case, is the force exerted on this object on an inclined plane like this here. Writing a simulation like that, it's not easy. Let me show you what the code looks like. Just to do that, just make that happen, all this was necessary. Oh, wow, that much just to do this here. So you may feel, this is impossible. I'm just going to play with this here. There comes the next question. Will I learn how to make these simulations? The answer is yes and no. As you saw here, this is quite complicated and takes a lot of understanding of programming as well as physics and mathematics. However, we can get you started on the right direction. So let me show you this one here. This is about an object that is falling, always falling, but never touching the ground. Why? Because as this is flying this way, the gravity exerts on this object and it falls. That's why it would have gone that way without the gravity, but it fell by this much. So what happens at this point here? Let's go there. It will fall even more. It would have gone that way, but because of gravity, it's falling. You see the blue arrow? So it's falling. What would happen at the end of there? It falls even more and more and more and more and more. So it keeps on falling, but as you see, it will never touch the ground. This is how the moon never hits the earth, always falling all the time. Or your direct TV satellite in the sky is never hitting us. This is called orbiting. So, wow, this is a complicated concept here. What does it take to write a code for this kind of a simulation here? Let's take a look. About 7 lines here. Of those, a lot of it is just painting it to the right color, drawing the arrow in certain way. All these are about drawing arrows and so on. And the only simulation, physics, was this line. And that's it. The rest of it was just painting and coloring and drawing lines. So it's not that difficult once you learn how to do this kind of understand the physics here. The rest of it you can add, package it so that it becomes a simulation here. So in this course, I will show you how to get this started, how to have this manipulate so that you have this kind of a parameter to control, and how to draw these lines, how to paint the body, so that as you learn more physics, more mathematics, and more programming, you will be able to build more and more elaborate simulations and visualizations. Here comes a heavy-duty question here. What can simulations teach me about the real universe? Think about it. Everything I showed you seemed like some kind of simplification, looks almost like a toy. So it's very nice and well that things are moving on the screen here, but does it have anything to do with real universe? The answer is yes. For example, let's take a look at this planetary motion here. When I simulate this here, you will see that no matter what I do, where I put it, no matter how I set it, it makes an elliptical orbit if I have only 2 bodies like that. When I add a 3rd body, then it's another story. It makes different things here, but by and large, the yellow one and this pink one are making an elliptical orbit to each other actually. So what? What do we care? It proves that Newton's universal law of gravitation is correct. When you observe the other end of the universe and you see 2 stars going in elliptical orbit, you know they are obeying exactly the same law as our Earth is obeying with the sun. There is only one law of physics in the universe. We are actually observing it. How do we know? Well, it's inverse square law is called. What if it's not inverse square law? So here you can actually simulate again. So here, this is a potential, not the force, so you have a different number. But when you have inverse square law, this number is -1. So when you have that, doesn't matter where I set the initial condition, where it starts, how fast it is. That doesn't matter what I do here. They are just different types of ellipses, extremely different ones at times, and at times they are just, I'm losing control over here, but nonetheless, they are all ellipses. Nothing you can do about it. What if they are not obeying the same law? What if Newton was wrong? And what would the end of other universe look like? Wouldn't they more or less draw this kind of ellipse anyway? We can find out. We can just enter different numbers there and see what happens. You would have observed this type of motion if Newton was wrong, or other universe did different types of motions here. So don't mind about this jaggedness. It will be smooth by the end of my plot here. So if you observed this kind of a planetary motion or stellar motion, you would know Newton was wrong, but it never happened. It was always this motion, elliptical motion. We cannot change the governing laws of physics of this universe here, but through the simulation here, we can play what if, and then we can actually observe what kind of universe we would have had. For example, continuing on this here, what if the gravity force was different, not an inverse square law? You would have observed this. You would have observed this. Observe this. Very interesting, huh? You cannot do this experiment. You cannot play with other stars. We cannot even go there, right? And yet, through simulation, we can do all this here. So this is the wonderful world of simulation and computational physics that we are going to learn. Of course, we are not going to learn the whole thing. We are going to learn how to crack open a little bit of the door so that you can see this wonderful world that is on the other side. And you will take one baby step so that you can take further steps as you study further math, physics, and computer programming. I hope to see you all in the camp so that I can show you what all these things mean and what you can do with them.